algebra. All right. So are there any questions? And actually, let me say this, just to get some questions flowing. We will have a quiz. Quiz. Quiz on Monday. On, let's say 5.4 up through 6.1. So this is where we started doing multiplying polynomials, right? FOIL method, if you like the FOIL method, distribution, all that kind of stuff. Up through 6.1, so I'm only going to have GCF and grouping. I'm not going to have any other factoring on there. Is that, you guys get that? So on Monday, quiz, 5.4 to 6.1. So maybe with that knowledge in our belt, are there any questions from homework?
Can we go way back?
Okay. Yeah.
Like 4.4.
Okay, sure.
Number 15 on 4.4.
Okay, so if you're going to set up something maybe a little bit more than a lemonade stand, so you set up like a little tiny building, you know, one of those little things where you can get coffee sometimes, so little 1-hour photo places, little tiny building, you're going to have some overhead, right? You're going to have to pay so much a month in cost, and maybe you're going to have some electrical costs and so forth. So every month you'd have to pay this much, plus some amount of money for all the materials you're going to use. So if you're going to make lemonade in this little kiosk that you got to pay for every month, then you have to pay, maybe this will be $85 per month for the lemons and the water and the sugar and the whatever else, and the special ingredients that makes it special for you, right? This will be how much money that you actually pull in. Now, what is the least thing that you would hope for in this case? What do you definitely not want to have happen in a business?
Spend more than you're making.
Exactly. So the least thing you'd want is for these two things to be the same. And that's what's called the break-even point. That's the point where both of these are the same. All right? So obviously, if I only make one thing, you with me? How much money do I make if I make one thing and sell it? $105. How much money do I have to spend for that month? $985. Holy crap. I'm a bit in the hole there, right? So there's a certain number of things I can sell. And why would this revenue catch up with this cost? It starts at 900 and it goes up from there. But the revenue, what do you guys notice? What's special about that number there?
Revenue is bigger than money.
Oh shit, looks like Y equals MSC, doesn't it? So how much is the cost going up as you make more and more of these things? It's going up by $85 per thing, but your revenue is going up $20 more. So at some point, this is going to catch up with this. So the cost might start off at 900, right? And go up from there. But the revenue starts at 0, and at some point it's going to catch up because it's going up faster. $105 per versus $85 per. You with me?
Yeah.
And we've all seen those commercials, or we've heard these things like, if you buy these solar panels, it costs so much, but in 2 years, you recoup the cost.
Yeah, it pays for myself.
And the savings, yeah. So that's the money that you got to shell out, but then you're paying less per month on that utility. Mm-hmm. So eventually you catch up, if it works correctly.
If the commercial don't lie. Yeah, this is good.
So,
So, 4.4
So all you have to do then is, like we said, what do you want to have happen? You actually want to make a profit. But to determine where you start making a profit, you want to see where these two things actually are equal, so that you come out even. So like I think I might have said something last time about going to a casino. Right? Did I tell you? Over the spring break I did go to a casino. I go like once every 5 years, it seems, on average. I don't like going to casinos, they depress me. But I came out of there losing a little bit, but the best you could hope for normally is to break even. Breaking even is like a really good day. We had fun and we didn't lose any money. Actually, it's good that we had fun and we only lost $50. You know, that's a good day too.
Yeah.
Especially if you have $50, I understand.
Yeah.
So if you let revenue equal cost, so 105x, the amount you pull in, if that equals the amount you got to shell out, you've broken even. You haven't made any money, but you haven't lost any money. So to really run a business, obviously you want this to be more, but this at least tells you the minimum number of things you got to make and sell to just break even. Then you make more than that.
So would you subtract the 85x?
Now you just solve it. Now you're back in chapter 2. Remember, I was going to say that a lot. There it is again. The minute you set up the equation, you're back in chapter 2.
Yeah.
Don't think it's something new. This is old.
So,
New, old. Solve.
So
Okay. Now that problem had something else specific. It said the most you can make is 38. But if you solve this, you see that x is 45.
is it 900 divided by 220?
Yes.
That's 45.
So if the most you can make is 38 things, whatever they are, 38 glasses of lemonade per month, and you need to make 45 just to break even, would you even start this business? No. So this is the kind of analysis you might do before you even set the damn business up, especially if you're a smart business person.
So this one doesn't break even.
Yeah, this one can't break even because the number that you have to get to, the problem says
Is less.
you can only go up to 38. Yeah.
Okay.
This is section 4 for you. Sorry. 4. All right. So any other questions from stuff? Yeah.
Just a refresher, do you mind doing that polynomial question real quick?
Yeah, of course. So what type of polynomial question? So do you mean like a like terms problem? Do you mean like a, is it a binomial trinomial problem? Do you mean like a...
Anyone that
So we have one area that gives a lot of people trouble is just like terms. But I'm hoping I keep going over like terms almost every day because we can run into things where we have to be able to combine things. Like terms means the same variables and the same amount of each variable. So up here, how many like terms do we have? 2. Yeah, I have 4x squares and I also have negative 6x squares. Now they can't make negative 2x4 or something weird. I don't have any x4s in there at all. The number in front keeps track of how many of these. So we got 4 of them and I take 6 away, I got negative 2 of right? Of them, sorry. So like terms cannot change exponents. What operation are exponents based on? Multiplication. So it's the only time they can change. When you multiply. Here I am adding, subtracting. They cannot change.
Only multiplication? Divided?
Multiplication, then division, sorry, of course. Anything that's, and to be honest, division is multiplication, just reciprocated, yeah. So it's the same thing. Yeah. So negative 2x squared, and this guy has nobody to go with, so he just stays the same. I'm not sure what I meant to be squared there, Jeff. It doesn't matter, not like terms. What type of polynomial is that? That answer.
Binomial.
Good, this is a binomial. I can maybe spell today. What's the degree of this term?
2.
This is a second degree. What's this term?
3.
3. Because the degree is the total number of variables I see. I see 2 x's and a y. That's 3 variables that I see. And what's the degree of this binomial? What's the whole degree? It's not 5. Good. It's the highest degree that I see. So not the most interesting things in the world. I understand. Definitions are never that way. Just don't lose points on that question, right? Yeah.
So the degree is like the total number of variables?
Yeah, the degree of a term is the total number of variables I see. So I see 2 x's and a y, that's why it's a third degree.
So if y had 3 on it,
It would be 5th degree. Exactly. I like it. So in essence, you just add the exponents for each term. The degree of a polynomial is the highest one I see, whoever wins. Okay. Cool. Everybody's still awake. I appreciate that. Yes. All right. These definitions will definitely put you to sleep. Just don't lose points. I mean, those are actually important to know how to tell what the degree is. Believe it or not. Is there another type like you can multiply these?
Can you do a specific one?
What's that?
I have a question like that one for a specific problem.
Okay, so like this, which one?
It has a fraction. It's number 40 on 5.5, page 3.
It might be the one we looked at. Let me see. Yes, we looked at that last time. So my suggestion on that one was to actually not do the multiplication, but so for example, to do this, what would you do first? Yeah, you do this, you distribute this to each. So you could write 4x times 3x and then on the next step do the actual multiplication. But this multiplication is not that involved. The biggest mistake I see is somebody says that that's 12x. And they're kind of mixing in their head multiplying and like terms. Like terms comes in when you're adding, subtracting. What's x times x? X squared. So be real careful. If you forget your power changing, you'll suddenly have maybe more like terms than you're supposed to on the next step. Bless you. And then where would this go next? Times the y. Times the -2. And then there's this guy's turn, right? -7y times 3x. Good, -21. -7 y squared, good. Plus 14 y. And now you look for like terms. Are there any like terms?
The xy's.
Good. So the 4xy, the -21xy. There's no other x squares, right? No other x's, no other y squares, no other y's. So the only ones that are like terms are these two. So then you say 12x squared. Good. 4 minus 21 is -17 of these. I like it. Minus 8x minus 7y squared. Oh, that word ay. Okay. All right.
Does it matter which variable you put first, like the y or the x?
Not really. In general, it's convention to put it alphabetically. But another way to look at it is it depends on which variable is most important to you right then. But for us, I'd say alphabetically is the way to go when you're not sure. Yeah. That way, it makes it easier to identify like terms if they're all alphabetical. Then they do look exactly the same. If this was yx, you might miss it. You might say there's no other xi's and there's no more yx's, but they're actually the same thing. Cool. Any other? Yeah.
You move the -7 with the exponent up to the front of that answer.
And to tell you honestly, if this was in terms of x, what I would do, if I wanted to put it in descending order by x, these two are sort of the same, so I'd leave those alone. And to tell you honestly, I would do this. Put that bigger y on the end there and the bigger x on the end there. Like that. But for us, it doesn't matter. Okay. Because there's, it kind of depends on what your next step is. If you're going to try to factor this next or something weird, which would be silly because we just multiplied it out. But it depends on what you want to do next. What order would make more sense. But that's, either one of those is fine. So any other questions from? Is there something from the outside world? Ask him this. That'd be very strange. My friend outside. Yeah.
It seemed like in the textbook they show they worded it to the highest exponent, the highest degree.
Normally in terms of one variable or the other. So this would be descending order by x. If I want a descending order by y, I'll put that first, that second, this in the middle, and that last. Yeah. Okay. Maybe. Okay. So any other questions?
The basic is number 2.
Oh, whoa. Yeah, we're not there yet. Oh, so please realize that 5-7, we're not doing 5-7, right?
No
Good.
5-7.
No 5-7. It's not in your homework sheet, right?
Okay, yeah.
Yeah, okay. So don't worry about that. The reason I did that is because we're going to come back to it in chapter 6 when it actually makes a little more sense.
Okay.
Yeah. Okay, so let's do this. Let's, was there another question? Everybody's on? Okay. Let's kind of review what we've done so far a little quickly. Then I want to try to get a few more forms of factoring under a belt. And as I promised last time, I got a little handout for you. It looks, well, it is a lot. But at the top I've got a bit of a summary. So you can just refer to the top for a quick thing. These are explanations of all the factoring forms. So hopefully that'll be helpful. We'll see. So what do we know so far? What do we always try first?
Write down numbers.
So if I'm given a factoring problem. That's right. Don't cry. There's no crying in factoring. What do you always try? I'm a teacher. You learn. Eyes in the back of the head, hearing out to nowhere. What do we always try first?
How would they all go into?
Yeah, I always try GCF first, right? Because it might be the only thing I could do, or it makes the problem easier to do. So let's do a couple examples of that. So I'm actually going to call it step 0, because it's always there. You always try GCF first. So here's a couple of examples of, and of course this means greatest common factor. Okay, so for example, example 1, something not too evil. So this is undistribution. I'm trying to figure out what did somebody multiply in. And there actually could be a lot of things, but I want to do the biggest possible thing. What's the biggest number that comes out of 9 and 15? 3. And what's the trick with the variables? How many A's can I take out? You find the lowest power, and that's what you can take out. If you try to take 2 A's out of him, he'd be cool. He would freak. So you take 1 A out. How many B's can you take out? 3. The smallest power on the B is 3. I can take 3 B's out. Then you say to yourself, 9 divided by 3 is 3. I had 2 A's. I took 1. I've got 1 left. I had 3 B's. I took them. No B's left. Plus. That's the conversation you have with yourself in your head. 15 divided by 3, 5. I had an A, I took it.
No, B
Go.
3.
I had 6 B's, took 3, I got 3 B's left, 11. How do you know you're done? No more numbers, no more letters come out. So I know I'm done. Alright, cool. So what about, let's try something that's got a little twist. We haven't tried this. Well, we'll see if you pick it up. You're right, though. You got the right first step. Yep. Yeah, it's the 9 there. So what number can come out?
2.
And by the way, whoever's texting, stop. Thank you so much. How many M's can come out?
3.
3. And of course that's the smallest power we see, so that makes sense. How many N's can come out?
4.
4, because the smallest one I see there is 4. I really want to make sure you guys understand that he can definitely give 3 M's. You can definitely take 3 away from him because you have 1 left. He's fine. And he can take 3, but you can't take out like 9 N's. These guys would both freak. That's why I immediately look for the smallest power to give me a hint. So now what's left in each case? 4 divided by 2.
2.
I had 4 M's, I took 3, so I have 1 M left. I had 9 N's, I took 4 of them, so now I have 5. And if you like it better, you're dividing. So when you divide, you subtract powers. So that's exactly why I just subtract in that case. Minus 7, had 9, took 3, I got 6, had 5, took 4, I got. And now here's where people freak out. This is not right. Because if you check it, I get this, where's that come from? If this is supposed to be the answer, I better be able to multiply it and get this whole thing back. So what has to be here?
1.
And another way to look at it, what's this divided by itself? 1. So either way you look at it, you need a plus 1 there. You can't divide and get 0 unless you started with 0 in the first place, right? So you're definitely going to have something left there. In this case, it's a 1 because you divided it by itself. Cool. That's the freakiest little thing about GCF is that. Be careful about that. Another way to look at it is how many terms did I start with? I better have 3 in here still also, unless there's some kind of light terms that's not going to happen. You with me? Sort of? No.
Like, I got everything up until the 3rd term. Can you explain to me why that turns into a 1?
Why is that a 7?
Because it's 14 divided by 2.
14 divided by 2. Okay, what's 2 divided by 2? What's m cubed divided by m cubed? What's that? Yeah, it's got to be 1, 1, 1, and 1. Cool. So 2 ways. You divide by something at 1, or it's got to be a 1 there so you get that back when you check. When you multiply it through, the only way to get that there is if there's a 1 placeholder there. Whichever way makes more sense.
But that wouldn't work if it was anything on the end other than the greatest common.
Exactly. Otherwise, if it was m4, there would be an m left. Right? It just happened to be exactly the same, so there's only a 1 left. I like it. Placeholder 1. Good. Okay. So that's GCF. What about the next type was grouping. When do I do grouping? Good. When there are 4 or more terms. So for example, if I had x squared minus 4x minus xb plus 4b. So does anything come out of all 4 terms? Because what do you always try first? You always try GCF. Does something come out of all 4 of these? Can I take an x out? The last two doesn't have an X, can I take a B out? Well, the first two doesn't have a B, can I take a 4 out? And then some of them don't have any number. No, I can't take anything out. So since there are 4 terms, I group them. So in fact, most of my colleagues and I, most math teachers, we try to teach this based on the number of terms. It's really nice. The problem itself is telling you what method to use. 4 more terms, try grouping. The trick with grouping, if you remember last time, they might not be in the right order, so if it doesn't work, you just try to rearrange it. Not a big deal. This case actually made it work here. What comes out of these two? Hopefully it did.
X.
X, and you're left with?
X minus 4.
So what do you want to have left here?
X minus 4.
You have to have the same thing, otherwise you can't do the last step, right? These have to be the same so that they can come out. So what do I take out of this to make an X here?
B.
And another way to look at it is you can tell a B comes out. You can see that a B comes out, right? But if there's more crap in here and you're not sure, there's a little clue. What do I do here to make this left? In fact, more than just a B, you take out a negative B to make the signs match up, right? So if you take out a negative B, that becomes positive X, because the B came out. Positive divided by negative is negative. Took the B out, so you're left with the 4. They're the same. I know I'm on the right track.
And that would be X minus B.
Yeah, and it really doesn't matter what order you write it in. Yeah. X minus 4 comes out. X minus B, or X minus B, X minus 4. I do not care, because they're both the same. Yes, ma'am.
Sorry, I'm confused on how you got the second one to be minus 4 instead of.
What's 4b divided? What did I take out?
You took away the negative b.
So what's 4b divided by negative b?
Negative.
Negative 4. Yeah. Cool. So if I take a negative out, both signs are going to change. This was negative, now it's positive. This is positive, now it's negative. Cool. Okay. So here, you guys try one on your own. Let's see. So don't freak out. There are 4 terms. This kind of problem, if there are 4 more terms, grouping becomes smaller GCF problems. So this is what math people love. I mean, you know that from experience. We love problems that have more problems in them, right? But to be honest, what's really going on there is I break that big, ugly looking problem down into smaller, easier problems. So the first thing is, does anything come out of all 4 of these? No. Some M's, Y's, and some have no numbers. So I see 4 of them, so I group them, these 2 and these 2. So then I focus on that like that's the only problem I gave you. If I said factor that, you should go, oh, thank God, give me more of that. Because what's the only way you can factor this? What's the only thing that you can do with this? What comes out of that? A y. They both have at least one y. So I can take a y out. And what's left? Good, there's 2 y's left there because he had 3, I took 1, there's 2 left. 7m because I took his y away. Poor little dude. What can come out of the other one? And then let me just make a mistake. So let's take an m out. What's left here? Negative y squared plus 7m. Are these the same? Don't worry, I told you I was going to make a mistake. Are these the same?
No.
No. What is it telling me? Why is it wrong? What did I do wrong? These signs are wrong. So I should have taken out a negative so that they would change. So I go, okay, let me just make that minus. That would now become a plus
What made you pick the M to take out in the first place?
because they both have at least one M.
Oh.
Yeah. This guy doesn't have any Y's. He doesn't have any number besides 1. But they do both at least have one M. Yeah. So now I know I'm on the right track because these two are exactly the same. If they're not exactly the same, do not create a next step. There is no next step.
Would that mean it's prime?
That would mean you made a mistake. Most of the time that's what it would mean.
And how'd you get
Or it's something you have to actually try to change the order.
Okay.
And more rare than either of those is it's prime. Right? So don't automatically go for the prime answer.
Did you get the negative 7M on the last part because of the negative sign on the top?
Yeah, when you divide positive 7m squared by negative m, you're left with negative 7m.
You're dividing it?
When I take something out,
It's dividing.
it's the opposite of distributing it in. So in is multiplication, out is divided.
Okay, and this one, if you change the order now, we will get same answer. But why, if you give me another one, the order is wrong, I need to change the order to get
So you
the
could
answer.
change the order in such a way.
This one, okay, I get the answer, same thing. If
Not if you
twice-
put that 7m squared here.
Yeah, no, I take second one with the
But
last
you're
one.
missing the point. There is an order that will not let the grouping work, and then there's at least one ordering that would let it work if it's factorable, right? So you certainly could change the order and it would still work.
Yeah,
Let's do the last step here and I'll show you. And you're right. What's the last step on this?
y minus one.
Okay, cool. You can do y minus m. Just don't do this. Why do you think somebody thinks that's necessary?
Because there's two of them.
Because they see two of them, but we know there's really just one that was distributed to both. So you don't have to put a square there. More than you don't have to. You can't. Right? Makes it wrong.
It makes it wrong.
Yes. Always a good reason not to do something. So what you're talking about is if I do the same problem, but I just change one little thing around. If I put this here, maybe.
Yeah, I guess same answer.
Exactly.
Yeah, but my question, if you said last time, I give you one, like this one, if it doesn't work, change the order, so you make it work. So why here, if you change the order, we get same
No,
answer?
well,
Why there?
be careful now. Just because I said if it doesn't work, change the order, makes it work, doesn't mean the opposite happens. I mean, that's the misapplication of logic, right? If it rains, I'm going to take my umbrella, but if I take my umbrella, it doesn't mean it's going to rain. So you got to be careful. It doesn't work both ways. Because I could take this and just move, real quick, I want you guys to be with me. What did I switch from the original problem to this problem? What did I switch?
The second one.
Yeah, I moved these two around, didn't I? Do you guys see that?
Yeah.
Now stay with me. I know that this is part of this is just me playing around trying to answer your question, but it's also still good practice for grouping. If I group this, what comes out of these two?
Y squared.
Y squared.
Minus m.
7M.
7m. And I took a negative out just to kind of cut to the chase here, right? Because I know I'm going to have to change a sign around to make it match. Negative, negative is now positive. Those are gone. So y, positive and negative is negative. Now notice something kind of interesting. What's the last step here?
Y2.
Okay, y squared minus 7m. Y minus m. Is that the same?
Yeah.
Yes. Turned around, but who cares? What was on the inside in this problem? Y minus m. What was on the outside in this problem? Y minus m. It's kind of nifty. Because why doesn't it matter? At the end, I kind of put them all together. It's going to end up in the same place. So it sort of makes sense that if I rearrange it, it should still come out to the same answer because it's the same problem. But there is an arrangement that I can't work with, right? If I take the same things and I rearrange this like this, right? You see that? So I put that Oh, I put a cube on it suddenly. Take that here, and then have these at the end. Are you guys cool with that?
Yeah, but then if
Alright.
you group them, the first one, nothing comes out.
Nothing comes out. So that's, if you hit a problem like this, it's got 4 terms, you know grouping is the way that you attack it, doesn't go anywhere, don't say prime, rearrange it. Now that doesn't mean that if it works, every rearrangement works. Of course not. Some rearrangements won't work. So they're going to give you in your homework some arrangements that do work and some that don't. You just have to rearrange it if it doesn't work. Okay, how are we doing so far? Set? So I really want to make sure the process is important. If it doesn't work, you try to rearrange it, and we just showed you that if you rearrange it, it might still work. If you rearrange it, it might then suddenly not work. So that's why if it doesn't work, it doesn't mean it's never going to work. You just rearrange it till it does work. Okay. That was a little deeper than I wanted to get in that, but that's all right.
Could you do one more?
Yeah. Let's do one that's a little bit more involved here. Well, it's not too crazy. Let's do that. I like it. Now this has got a bit of a twist to it, and I'm going to do it, unless I get a suggestion that tells me otherwise, I'm going to do it the way that most of you guys would probably do this. So here we go. How many terms are there?
4.
4. So if we group these and group these, what can come out of here?
X.
X and a Y, is that cool?
Yeah.
And then what are you left with here?
X, Y.
Good, because you had 2 of each, you took 1 of each, so you have 1 of each left. Here you only had 1 of each, so he's got none left.
So,
Okay. What definitely has to come out of the second one? What sign? It's got to be a negative I'm taking out, because I know they got to both end up positive. Do you see that? So I know I got to take a negative something out.
so if that one's positive, what you.
This has always got to be the same as that.
So.
They're currently both negative, so I've got to take a negative out to make them both positive.
Oh, got it. I see it.
So what number can come out? 6, and the only letter I can take out? X. Okay. And what's left? And so these are the same, so I know I'm on the right track. So what's the last step? I'm trying to give you a big hint.
6x.
So xy minus 6x.
XY plus 3.
I like it. That's fine. Or the other way around, right? Okay, the xy plus 3 first. I love it. Now, why is that actually not done?
Can you still take out the
Yes. I can still do something here.
Oh.
And from the very beginning, I was hoping maybe somebody tell me, Jeff, you got to do GCF first. Because what could I have done at the very beginning? What do they all have? X. I could have taken the X out first, but if I don't, I end up taking the X out last. Who cares? Do you see what I'm saying? I mean, eventually you're going to see I got to be able to take it out. So out of here, can I take an X, and what's left? Y minus 6. Good.
Okay, because you can't factor the other.
Because nothing will come out of the other dude. But I did take an X out of him. Because I forgot to take it out at the very beginning.
So if we didn't do that last part, we would be wrong.
Yes.
Would you get
You'll be partial credit, but you'll miss that last step, so you'll lose some points for that. Not all of them, don't worry. Okay. So then last time we got into what do you do if you have 3 terms? Which kind of makes sense. It's kind of going with the flow. We did always try GCF. What do you do if you have 4 or more terms? So then what do you do if you have less than that, for like example, 3 terms? So it'll pretty much look like that. People kind of freak a little bit when they have so many letters in an expression. But just to give you an example, if A is 1, it's relatively easy. Notice I didn't say it's easy. I said it's relatively easy, so I cover my ass there. In case you find it difficult, it's not quite as difficult as if A was not 1, if A was something else. That'll be a little bit more difficult. So for example, does anybody remember how to look at this to figure out how to factor that? What form will the answer
3
take?
to 5.
Yeah, good. So somebody remembers. It's all about the numbers at the end. Because what definitely goes in the beginning? X and x. Because when I multiply that, I get x squared. So it's all about what numbers are at the end to make the middle come out to be 8x, which is addition. So I need 2 numbers that add to be 8. And those same numbers have to also multiply to be 15. So that, like you said, is...
Oh, that's when you do that.
That's when you do that.
Gotcha.
Exactly.
That's when you do that.
5 and 3.
5 and 3, exactly. So you can start doing factors of 15. There aren't that many. 15 and 1 don't work worth anything. That would make 16. So it has to be 5 and 3. So you can do that, or of course this.
So is it 5? That's, yeah.
So either one of those. So if there's a 1 out front, those are truly a one-step question. That one step really being this. If you get the numbers that make this and this work, you're done. Kicks ass. And we always forget why it's that easy. So we start to lose faith in it being that easy. We start to question ourselves and saying, no, it can't be that easy.
What if it's a 2?
We'll get to that. Don't worry. We're not quite there yet. So for example, if I had no. Sorry. Yeah, that'll work. I was thinking the other way around. So what's got to be true about the 2 numbers? Because the reason, I really want you to understand why it boils down to 2 numbers. I know it's going to be x and x, so there's no mystery there, but the numbers that go there is the only mystery. 4 and 3, and they both have to be negative. They have to be the same sign to multiply to be positive, so that middle term tells me they're both negative. And 3 and 4 make 12, and it also makes 7, negative 7, so they got to be both negative. So don't make that problem into something more than that. It isn't. It really should be a one-step problem. And I have no idea if any of you appreciate, or if it makes any sense when I do the little side step, if I let x be something and then that's how I factor it. Does anybody appreciate that or like it or
The what?
don't care about it? Because in this case, if x were 6, what number is this? What's x squared? So I get 36 minus 42 plus 12. So that's equal to 6. That's interesting. You guys with me so far? So if x is 6, this is that. This is 6. And my claim is that these are the same, right? Isn't that my claim? I'm saying that this is the same as that. If x is 6, what's this? So that's 3. 6 minus 4 is 2. 3 times 2 is 6. So that is a way. If that was 6, one way to factor that is 3 and 2. You with me? So any number you pick for x, that's going to work the same damn way. It's kind of nifty. So again, like I said last time, when you factor this, it's difficult because you're actually factoring an infinite number of numbers all at once. Because what could x be? Any damn thing. I like it. Do you ever have to do that yourself? No. You don't. That's just me doing weird shit on the side. But I like to show you the concrete side of this abstract problem. So what about this here? Why, Jeff? Why? 240 sucks. Why is 240 kind of suck? It's nice because it's a round number and all that, but it's big and it's got a lot of what? Factors. And that's what we're curious about here. Because our two numbers that we need have to do what? Add up to be 8 and multiply to be negative 240. So one approach to this is to just start listing all the factors of 240 you can imagine. And you could eventually hit it. You could do it relatively quickly. It could take you all day. Right? You with me? Maybe some of you guys are with me a little bit. All right. So the quicker way, and you never have to do this way. The hard part for students to understand about math is you can make it your own in a lot of different ways. And you can never do what I'm about to tell you. You can always do this. You can even do, here, let me show you one little thing before I show you the other way. Give me one way to factor this, and maybe, let me give you one way, just in case somebody gets the answer too early. 24 and 10, right? Now, one thing you can do is you can start to rearrange these things. Isn't this 12 times 2? And is this 5 times 2, for example? Now, let me just show you this. Some of you guys might like this, and some of you guys might not have a clue what the hell I'm talking about. But can't you then say maybe 4 times 60? Do you see I can put the factors together again? So you could actually, if you really wanted to, and some people like this method, this is not a bad method. You can kind of break these down into different ways and put them back together in different ways and get whole other numbers that you might not otherwise think about. Some of you guys might not like it, and that's just the way it is. That's how you make math your own. You do it the way that you like to approach it. So if you don't like that way, let's try this way. You just told me that they have to add to be 8 and multiply by 240. Who said they had to do this first? Let's first see if they add to be 8. Give me two. Now, what's true about the two numbers? Are they going to be the same sign?
No. 20.
No. So over here, I really should be like that, right? So they got to be different signs, and they have to add to be 8. So let me start us off. Negative 12 and 4. Actually, good job, Jeff. So 12 and negative 4. Doesn't that make 8 when I add them? Well, what's it multiply to be? Negative 48. Way too small, right? So let me just pick my numbers up. Maybe 18 and negative 10. Doesn't that add up to be 8? You with me? I just need two numbers that add to be 8 and multiply to be 240.
Negative 12 and 20.
Exactly, I like it. I'm getting there. So she's in the front. Get to the answer. I know the answer. Stop. But this comes out to be negative 180. That's still a little bit too little. So then if you try 20 and negative 12, that still adds up to be 8, right? And they multiply to be negative 240. So that's my answer, x plus 20, x minus 12. Cool. So you have at least 3 different methods right there you can try. You can just try to make a list of factors. Just keep going, keep going, keep going. And that's the way it's normally taught. Just list the factors until you get the right one that makes 8. Sometimes you'll hit it quickly, and sometimes it'll take all day. Or you can make the list that add to 8 and then check to see if they multiply to be 240. That's easier math, actually. Or you can do this thing where you start playing around with the factors, if you like that. Yeah?
There's always one answer only.
Yeah, there's only one way. Yeah, of course you can write these in the opposite order, but there's always only one possible answer. Yes? Okay. So let's do this. Let's talk about what to do if the first number is not a 1. And then I'm going to give you guys several to try to do together or by yourself if you want to. Then we'll see how much time is left. And I might talk about a few more factoring methods. Okay. So I've got a certain way that I like to teach this. There are many ways to do this problem, and I will sort of reference them, especially if they come up. But I have a certain way I like to teach this problem because it actually gets you to practice some other types of factoring along the way. And it's a nice process because a process will always work and it will always be the same steps no matter what. So for example, I want to know how to factor something like 4x squared minus 5x minus 6. Now why should that be any different than what we were doing before? So let's take a second and look at this. Why can't I just say what two numbers multiply to be negative 6 and add to be negative 5? Why should that not work anymore? Let's try to do what we did before. Where would something come from that has a number out front that's not 1? I don't know if you guys remember, because how did we figure out the other way to factor things? We actually started with the multiplication and we try to see patterns, right, to help us figure out a method. So in order to have a number out front that's not 1, I can't just have x and x there, can I? So maybe I could have like 3x and 4x. So obviously this is not going to be that problem. I want to work that problem out. But let me do a sample problem to see what's going on. Now stay with me. I know that my explanations of why things work take a while, but then I'll focus on how to actually use it in a problem. So let's just say over here could be almost anything. Let's make it plus 2 and plus 3. Why not? So I want to make sure everybody's with me. This has nothing to do with that problem directly. What I'm trying to do is, what kind of problem would lead me to something that doesn't have a 1 here? So obviously these can't both be 1. So here's one example. What do you get when you multiply this out? 12x squared
9.
plus 9x plus 8x plus 6. So I get 12x squared plus 17x plus 6. Now what used to happen, let me see if I can get you guys with me. When I had just a 1 out front, if I multiply that out, I'm going to get this here. Right? This is what we did before, and that 12 came from 3 times 4, and that 7 came from 3 plus 4. That's why the middle number is, they have to add to be it, and the last number they have to multiply to be it. You with me? Is that still true? 3 times 2 is 6, but 3 plus 2 is not 7 freaking teen. Right? Therefore, the old pattern doesn't work. Why the hell did this become 17? Because these stupid things messed with these, didn't they? I didn't just do 2x and 3x, I did 9x, shit, and 8x, because these stupid numbers here messed with it. How are we doing so far? You kind of follow why I can't do it the same way. On this example, I can show you something kind of cool. Whenever there's a number out front that's not 1, you have to take it into account. So what you do is, the first step is you multiply that by the last dude. Then you find factors of that that make this. And let me show it to you right here. This is kind of cool. What's 12 times 6? 72. And look at 9 and 8. Don't those add to be 17? Of course, because that's where the freaking 17 came from, right? And what's 9 times 8? 72. I love it. So, in general, I've got to take that number into account because it does mess up my middle term. It does come into play in my middle term, so I've got to take it into account. So I don't find factors of 6 that make 5. I find factors of 24, well, negative 24, that make negative 5. Who thinks they have that? What two numbers make 24 when you multiply, 5 when you add them? One of them's going to be negative, right? I love it. So it's definitely 8 and 3. And if 8's negative, that makes negative 5. Do you see that? All right, so how do you feel about this so far? This is one little thing you do. And to be totally honest to you, don't write this down, but just look at this. Stay with me now. When you factor this, what would you do? 3 and 1, and then you're done, right? You put those in there. On this problem, I can't just throw those in there, right? This is 3 and 2, but this is 9 and 8. That's the numbers I would get from 72. So I'm going to do this whole process here backwards. So I'm going to rewrite negative 5x. I'm going to rewrite it as negative 8x plus 3x. Now what the hell does that do for me? How many terms do I suddenly have? 4. And what can I do if I have 4 terms? And grouping should be relatively easy. So I want you to realize what's going on here. The name of this method is called the Surefire Method. I did not name it.
Right.
Oh, it sounds like something I would say, but I cannot take credit for that. And what it does is it makes a 3-term problem into a 4-term problem, because a 4-term problem is always easier. You just got to group it. That's just GCF. I know we just learned grouping, but it's easier than any other forms of factoring. Yes, ma'am?
So you say break it up, like?
And the only way that will make it work is the way that you find here.
Okay, so multiply the outside numbers. and
Find
subtract
factors that make this, and then break it up with those numbers.
after you multiply the outside numbers to.
Exactly.
Okay.
So you multiply that, you got to take it into account. Find factors just like you would have before, but then break up the middle term. And now you group these. Right? Don't worry, we're going to do a couple more of these. This takes a little bit of practice to get used to.
You'll get the same answer.
What's that?
You'll get the same answer.
You'll get the answer, yes. We haven't gotten an answer yet, so I can't get a same answer yet. So we'll do another couple and then we'll take a break. What comes out of these two? You have 4x. Three. X minus 2. So then what comes out? How do you write that now? Okay, 4x plus 3. X minus 2. I love it. There you go. And then you can check it and all that kind of stuff. It'll definitely work. So there are, I want you to realize, there's a lot of numbers I can put here that would make this work. Could I put negative 2 and negative 3? Negative 6 and 1? But the only way that's going to make the grouping work is the way I would find right here. Yeah?
So you do the first step first, and then you turn your 3-term problem into a 4-term problem. That's a step.
And a 4-term problem is grouping.
And then you end up with.
And then
2
you're done.
So the answers are always 2 things in parentheses.
So figure out a way to make it so you can get them.
All right, let's do a couple more. I think I just said that, hopefully. A couple more examples, and then we'll take a break. Now, what do you always try first? GCF, because if I could take a 6 out, that would be so kick-ass, because then I wouldn't have to do this slightly more difficult process here, right? If I could take a 6 out, there'd be a 1 left, I can attack it like I did before. Unfortunately, Jeff made a problem that you can't take that out. But if you hit that, definitely try to take that stupid number out first, because then it would be easier. That's what I mean by GCF is always first, because then it makes the problem at least easier to look at. So what's my first step here? It's got 3 terms, so I know I have to attack it. Can't take a 6 out. Good. So you have to take that into account. You can't just find factors of that. You have to find factors of negative 60.